and hello student. My name is Ashok Sitala. In this session, we learn the hexadecimal number to decimal number in C language. So let us start. First, I share my laptop screen and fix the position here so you can watch better my video lecture. And here Turbo C++, I double click and take some process, and now yes is open Alt F file menu, taking new file, and here our goal, write a program to convert hexadecimal to decimal number. So yes, that perfectly. That is our definition. So you have to not divide and conquer what is input, what is process, and what is a output. So here that input is a hexadecimal, any number, and then convert equivalent to decimal number. That is our output. And how to convert hexa to decimal, that is our process, or we can apply this process to logic in C language. So yes, that is a decimal 0 to 9, that is a base of 10, and hexadecimal number, so 0 to 9, and capital A to F, so 6 digit, and that is a base of 16. So now we can understand one example or some paperwork. So always you have to do some paperwork and apply to your C program. So capital A 19, so that is a like one hexadecimal number, and we can convert into equivalent decimal number, so that is a base of 10. So yes, you have to know we can separate, means that is a 9, so I can explain in step by step. So here that we can 9 multiply 16, and upon that sign I can use in C language, so 0. So then we can solve. So what is an answer means, and now that is that second last digit 1, then multiply, yes, and 16 upon 1, so that we can solve. Next capital A, so that is a digit of 10, and multiply 16 upon 2, so that we can solve. Now we can, yes, in we can say that second step, so like this statement, first that is a 9 and multiply, so any that upon in maths 0, so that is a 1, so here that answer is 9. So yes, I think perfectly. Now here what to do, 1, yes, then multiply, that is a 16, so 1 any sign, that is upon 1, so that is a same number, so we can get as a 16 answer. And now that is a third, so here we can say that 10, yes, and multiply, that is a 16 upon, so that 16 multiply 16, so 256, yes, that is I think 256 perfectly. So here that is a, yes, 2 pi 60, so multiply 10, and now we can what to do, summation all these three number. So let us check in next line. So here we can say that first 6 plus 9, so that is a 5 and 1 carry, and that is a 8, and here 2 pi, so 2 pi 8 5, that is our answer. So that is the equivalent of, we can say that 10, that means decimal number, so hexa to decimal. So that is a process, and now we can apply this process. So 2585, that we can take answer of when we can input capital A 19, so that is a hexa to decimal number. So let us start. And yes, I first give multi comment line, so yes, that is a perfectly, yes, here that is slash, and now first include our header file, so stdio.h, and then we can include as a conio console input output.h, and here we can use as a string, use string handling function, so we can calculate string length. And next we have to use also power function, so that is a base of 16, so power function we can, so I take as a 4 header file. Now coming to main our function, and now we can declare first some variables, so character, hex, and then assign 16 to, that is assigned to 0 all. And now we can take some integer variable, so we can uh, des yes, first I take as a I, and then decimal, so 0, and then we can take one counter, so that is a, we can plus plus, and then we can digit, so that is also 0. So all, so let us check, there are four integer variable and one character 1D array for hex. So let us first clear the screen, and we can take one number from user. So here one message, enter any hexadecimal number. Yes, and that number, so I use direct get s, so because that is a 1D array, so we can say that hex. Yes, and now what to do? So here we have to know that is a starting and ending. So that is a number programming. And in my previous all video lecture, I take as a while loop, but here I take as a for loop. Why? So let us check why. So here that we can use string length. So that is a perfectly, and -1. So hex. So that because that our index start with 0 in array. So you have to know index start with 0. So we can length -1. So hex we can scan, and then length -1. So that is a number of time loop is, for loop is repeat. And now what to do? So I is greater than equal to 0 and I minus minus. So that perfectly. So I initialization, so we cannot initialize any value here. The three variable initialize 0, and hex we have to scan. So all variable you can initialize properly, otherwise you have to know in C that is a some take garbage value. So now what to do? Now we can take as a switch case and pass our hex of I, that is a 1D array. And now we can take some case of, that is a, so we can say that capital A, yes, and colon sign. And now what to do? So digit we have to initialize 10, yes, in capital A, that is a 10, and then we can break. So I copy, that is a 6 digit used in hexadecimal number. So capital A, and capital here is B, then here C, D, then E, and last one is a F. So you have to know here 10, 11, then 12, 13, 14, and last one 15. And now we can take as a default case. So that is we can take and that digits initialize. So we can say that hex of I, and that -0 x 30. So what is that? This, yes, why we have to minus? So let us I explain afterward. So here that our switch case, yes, is a complete, and then switch case after we have to take initialize to our decimal plus equal to, and that we can digits and multiply power function to use. So that is our process. Yes. So let us check what is this. We can type casting in double data types. So double, and we can take as yes, here that first argument 16, and that now I again use as a double type casting, and here we can pass as a C variable, that is our counter. So yes, that is a bank. So first we can initialize C is a 0. So that is our process. You can look here. So first is a 0, then 1, 2. So yes, we can count plus C means C we can take as a plus plus. So that is a perfectly. So base of 0, and that our digits separate. So same process we can do as a paperwork, but only we can understand what is a this. Yes, then we can understand, because you have to know A to F is a 10, 11, 12, 13, 14, 15. Yes, that is you have to understand. So only one line we can understand. So all are we can understand in this logic. So yes, first I can print our hexadecimal number. So here that is equivalent to the decimal number. So hexa, yes, here let us check. So hexadecimal to decimal number, yes, or equivalent, you can also write that type of. So hexadecimal to decimal number, and percentage D, and I print is a DEC, yes, and get ch, that is a perfect. Now all are well. So let us check any parenthesis is remaining. So here that is a typecasting, yes, and that is a power function, yes, here that start power function to here and complete to here, and that is a our that all parentheses, so multiply and assign, yes, here plus equal, so that is a full form. I just write DEC plus, yes, so I think you have to know, so that is a compound assignment short technique, and then we can upon, so 16 upon 0 1 2, that is a any, and I save this file, so we can say that hex, and that is ec dot c, so hexa to hexadecimal number to decimal. So let us check any other. Yes, here, yes, one parenthesis is remaining. Yes, that perfectly. So because here that we can initialize I to our 1D array hex and -1, because array start index is 0. So all is well. So let us compile. Yes, there is no any error. So that perfectly we have to apply to our coding. So very simple coding, so only we can understand, yes, what is this. So just let us, I open our comment multi, and then what is a 0, yes, x and 30. So yes, that is a rare case we have to use, like in the HTML code that used in hexadecimal number. So that is we can define that hexa to equivalent to decimal number. So that is a hex. So 0x is a represent is a hexadecimal number. And what is the meaning of this number? So we can convert of this process. So first last digit you can multiply, that is a 1. So 0 in maths rules, multiply all are 0. So that is a 0. Now second last digit we can multiply to 16. So that is equivalent to decimal. So here that we can say that 48. Yes, so that is a this number equal to, that is a decimal number 48, and other if any number. So that is a process. Zero of first last digit you can multiply 1, so that is a here is 0, but any number you can multiply 1. Then second last digit you can multiply 16, and then third last digit you can multiply 16 multiply 16, and then fourth last digit is there, so you can multiply 16 then 16, then 16. First 1, then 16, 16, and 16. So that is a process. So every time 116 is included. Now here, if any other number is like look 3 digit, so we can 1, then multiply 16, yes, and again multiply 16, and then fourth digit, so that is a 16 multiply 16, then multiply 16. So that is a process of that equivalent we can get. So here that only is a -30, so every that digit we can take as a -48, so we can get that equivalent the exact decimal number. So you can also search in Google. So 0x30, what is a decimal number, or you can say that hexadecimal number. So that is a equivalent table or that conversion process you can that describe. Okay, so I explained to you, yes, first last digit you can multiply 1, second last digit you can multiply 16, then third last digit you can multiply 16 multiply 16, and if fourth last digit is there, so you can multiply 1, then 16, 16, and 16, so 3 times. So yes, that is a process. So now I hope you can understand what is this. Yes, so that is a rare case we have to use in our logic. So let us check. Now I compile, yes, already, and run. So we can our paperwork hexa one, a capital A 19. Yes, that is our. So let us, yes, you can look. So 2585 we can already solve. So we can show that is a perfectly our hexa to the hexadecimal number to decimal number. So yes, again I run, and we can say that E1. So yes, 225, yes, that perfectly. And let us check. I 1e, so that is a 30. Yes, perfectly. And now we can take like 9de. So yes, 2 5 2 5 2 6. Yes, that is a perfectly. So I also solved that paperwork in my book. Yes, and now we can take as a watch window, so alter w, and here that is a watch, and alter w, and we can take output window. So let us check. Yes, I some size is decrease, and we can set our watch. So first we can take our variable. So declaration order I set follow this watch window. First is a hex of I. Yes, then we can take as a I. Yes, then decimal number, then counter means upon, and then last one is a digit. So all that perfectly meaningful, and five variable we have to use. So now I can alter R, so we can trace into F7 function key I press. So our watch is start, and look that X is assigned to 0, and then I we have to here in for loop assign initialization. So all three that integer is a 0. So no any garbage value. Yes, only I. But I we can also, yes, our output is clear. I we can initialize in for loop. So enter any hexadecimal. So same I can input our paperwork A19. So let us have that, yes, that I now initialize garbage value is now gone. So I press F7. So you can look that is a I is 2 because there is a digit is T, but that we can minus 1. So I is a initialize 2. So because that is a index start with 0. So I is greater than equal to 0. So I here we can digit is a 3, but minus 1. So that I initialize 2. And that our number is a 9, last digit. And now that pass in switch case. So there is a directly in default case, and adds that minus, so that is a minus that code, so that is a perfectly. So let us check what is a digit. So you can look that is a digit taking as a first, that is a here that is a 9. Yes, and now 9 upon that is a c 16 upon 0. So that is an yes, store in decimal, that is a 9. You can look that is our first answer, solve as a paperwork. So that is a 9 multiply 1, so that is a 9. Yes, and again c plus plus, so that is a counter. So that is the best we have to take in this logic. And now again that is a I minus minus. Yes, so I 1, and our digit is also 1. So that is also take in default case. Yes, so here again that minus this code, so hexadecimal. So that is a, you can look here digit assigned to 1 same, and then 16 upon 1, and multiply digit is 1. So that is a 16 plus 9, so that is a 25. Yes, that is our answer. And now I plus plus, so that is the last time. Yes, that capital A, yes, that digit assigned to 10. Yes, that is our first case, and bracket, so that directly 16 upon 2, and that multiply 10. So that you have to know 256 and multiply 10. So yes, here our answer is ready, 2585 or 2585. Yes, and now there is our condition, because I minus minus, so that is a minus. So I is greater than equal to 0, so that for loop is false, and our answer is that perfectly clear. So yes, I hope uh, you have to understand. So that is a very important. This we can take same our appropriate digit in decimal number, hexa to decimal. So that is a very important, this logic. Only one you have to understand this logic, and also I explain how we that convert. So that 0 that multiply means last digit multiply 1, second last multiply 16, third last 16 plus 16, fourth last digit that 16 plus 16 plus 16. So that is a process, and that minus in our current digit. So that is a our required output is coming. So just write this program to your C notebook if you prepare hexadecimal number to convert in decimal number. So that is a base on 16 hexadecimal number, and decimal is a base of 10. So first we have to done as a paperwork, and then we can apply this process to our appropriate logic in C language. So I hope you can understand and enjoy this session. So now I can close this file Alt F3 and watch an output window and quit. So any doubt of this definition regarding, so you can write in comment section. I give the definitely answer to you. Thanks your watching, supporting, and sharing, and subscribe my channel Ashok Sijalakati and press the bell icon to never miss any again. So thanks again and Hare Krishna.